Solar Cycle 25, expected scenes and threats while still peaking. In May, powerful solar storms sent stunning auroras to rarely seen latitudes. These light shows graced areas as far south as Florida and Texas, delighting spectators. However, the current increase in solar storm activity, known as Solar Cycle 25, won't peak until the summer of 2025, meaning we may see more of these northern lights in places we're not accustomed to. Kevin Stern, Senior Research Associate at the Super Dual Auroral Radar Network at Virginia Tech, explains, geomagnetic storms can produce auroras at lower latitudes, but they can also increase radiation exposure to communication and other satellites. This increase in radiation can damage or enhance the degradation of satellite electronics, shortening their lifespan. The solar cycle repeats every 11 years, but we're currently heading towards a peak. Stern notes, we're seeing more solar flares right now because we're approaching solar maximum, which is signaled by the highest number of sunspots. However, not all sunspots produce flares. For a sunspot to produce multiple flares, the magnetic fields need to be aligned in the right way. Stern compares the fluctuations to winter storm activity, which could drop as much snow as several years' worth of snowfall in a single winter storm event. Considering the solar energy maximum won't reach its peak until next summer, it means more chances for these amazing light shows but also potential communication disruptions. Stern explains, the northern lights are a visual manifestation of the Earth's magnetic field reacting to a geomagnetic storm. Typically, the stronger the storm, the farther south the northern lights will travel. Recent storms have caused timing delays in GPS units in agricultural equipment. However, they weren't as powerful as the 1859 Carrington event, the most powerful geomagnetic storm in history, which disabled telegraph communication worldwide. What would such a storm do to our much more advanced telecommunications infrastructure today? Stern says, it's hard to gauge the likelihood of an event that rarely happens when we can't easily test our communication networks against it. This is where many researchers are working to model these storm time events so we can try to simulate how a modern-day Carrington event would affect our electronics. Stay tuned as we continue to explore the fascinating world of space and science. Don't forget to like, share, and subscribe for more exciting updates.